You ready? Hello, everybody. My name is Charles, and I've been making circuit boards for 68 years. No, since 1968. That's 53 years, something or other. I don't talk to people very well. I make circuit boards. I've been making circuit boards, most of my life. I'm going to read a little bit of notes, and then I'm going to change the way this thing works a little bit because I just don't talk to groups. That's not what I do. I was making circuit boards way before they had personal computers. Does anybody in here remember Bishop Graphics? No. Does anybody remember Bishop Graphics? It was a company that made little markers that have 8-pin markers, 14-pin, 16-pin, and you put them on paper, and you had different size tapes. They made that, and you drew out circuit boards. And this is before we had computers. I've been doing this for ages. I really understand and love making circuit boards. That's what I do. I was making circuit boards before I got married. I married a very nice young lady, and she understood. I love circuit boards as much as her, because that's what I do. I make circuit boards. She got ill a few years ago, and she couldn't stand the smell of making. I assume everybody knows how to make circuit boards. Yeah, wave there. Circuit boards are made with chemicals. You etch circuit boards. But basically what a circuit board is you have a component you put on a circuit board. A circuit board is covered with copper, and when you put a trace on it, it's an island. That copper doesn't touch anything else. It goes to another component or several components. And so that is the basic idea of circuit boards. And I try to make circuit boards without doing etching, without having any chemical smells or anything. And so I started using a CNC machine. Everybody knows what a CNC machine is. Everybody knows what CNC machines are. And so I started cutting circuit boards, cutting the copper off the back of circuit boards, and you can do this at home easily with a matter of minutes. And in order to make this easy, I decided to write a program, which I'll be glad to give everybody a copy of the program if you're interested in making your own circuit boards. I had some 12-year-old kids. I was working with a Boy Scout group, and I showed them how to use my program, and within an hour or so, they were making their own circuit boards. They're not fantastically great circuit boards, but not every circuit board has to be fantastically great. And so, but basically, I don't talk to people very well. I talk one-on-one. I'm an introvert type person. So I've got somebody here, Mr. Frolic. How are you doing?
I'm doing well.
What's new with you?
Not much. What's new with you?
I've got a software program called EasyCut.
What's EasyCut do?
EasyCut makes circuit boards. It's super simple, super easy. Can I show you how to do it?
I'd love to see.
Well, first off, you bring up EasyCut, and it gives you a grid. This grid is the layout of a circuit board. It's roughly 4 inches by 7 inches. The reason I'm using inches is because that's what I grew up with as a hobbyist, and people in America use the imperial measurement system, and a lot of connectors are in 1/10 of an inch spacing. So I have 10th-inch grids on my circuit board. There's basically only 2 things that my design does, my program does. It puts holes on the circuit boards, and it cuts out traces. And the reason I cut out traces is because we're cutting islands. So if I start off, we want to have a, first off, I wrote software. I'm not a software person. So I have a lot of errors and mistakes in my software and a lot of peculiarities with it. And my software will not do anything until you create a file. I do not allow you to play with it. You can play with it if you have a file. So in case you do something nice, you can save it. Or if you don't like it, you don't have to save it, but you can't do it until you have a file. So let me come up and create a file, and we have a file. We're going to call it new, and we'll call it, if I can figure out how to do this, we're going to call it Frolic. F-R-O-L-I-C-X, I think. And I'm perverse, and you have to make the file called WRK. I won't look at it and play with it if it's not WRK. And so it's a work file.
You might also add that your program is written entirely in one language?
It's written in a language called Free Basic. The reason I use Free Basic is because some 60 years ago, I learned how to program in BASIC, and I'm kind of old, and I just don't really learn stuff very new anymore, so I stick with something I know. I studied it. Free Basic will work in Linux, it'll work in Apple, and it'll work on Windows.
Someday, working on it.
No, Free Basic works in Windows. It's just that my program uses a lot of something called GTK. It's from the GIMP toolkit, GTK3, and you have to have hundreds of libraries to make it all work. I did try to make it work in Windows, and Windows came up and said you're missing 38 libraries, or excuse me, 40 libraries. And I found 38 of those libraries, and I'm still trying to find the last 2 libraries. And when I get those, if somebody knows anything about Windows and knows how to put libraries together, I can get my Free Basic compile under Windows. But right now, years ago, I got confused by Windows, and I started playing with Linux, and I've played with it ever since, and I can't understand Windows anymore. So I apologize to that for everybody. But that has nothing to do with my writing a piece of software. So first thing I do is I find a file name. Next thing I do, I have 3 actions I can do. One is drill holes. So I come over and I can't teach people how to make circuit boards until you have a design. I can't teach people how to design circuit boards. If you don't have an idea of what you want a circuit board for, I can't help you. But if you kind of know what you want to make a circuit board for, would you like to make a circuit board to put a resistor on one LED?
I'd love to add a resistor and an LED to this board.
Okay, well, let's have a through-hole mount resistor, and I'm going to come over here and start up 2 inches and put a hole in there. And I'm going to come over, it's supposed to be 5/10 of an inch, I think. I don't know if that's correct or not. And we'll put a hole there. Can everybody see that? And then I'm going to come over and put me an LED, and the LED is going to be 1/10 of an inch pins apart. This is a through-hole LED, and we're going to put two pins there. And now I have a layout for a resistor and a LED. The program does not let you put items on the board yet, so you can tell where your components and parts are. That's something I might be able to add later. I've been making circuit boards so long I don't need that, but everybody else might need it. So it's
the footprints live in your mind.
And so I'm going to come up and I'm going to get a little bit weird, and we're going to come in and add a couple more holes. I'm going to come down and put in power and put in a ground. And so I know where they are. I want to hook power to my resistor. And so I'm now through drilling holes. I'm going to come up and say, let's cut a trace. And I'm going to change this to cut a trace. I'm going to come down here and start at this spot, just because I arbitrarily can. It's no particular reason. Come over and cut this spot. I'm going to come up and do weird things. Cut this spot, come over to cut this particular spot, come up to here, cut this out for this resistor, which is a totally wrong place to do it. Come back over here and come down, and I've now finished. Whoops, I messed up. Let's back up a space. Let's back up another space and come down and put this in a little bit wider path. Come down, I hit the backspace key to back up. I hit the enter key to go back forward. Put this space in and come down and hit this space and end up ending the cut. So now I've cut out a copper path from my power to my resistor. Now I need to hook my resistor to my LED. So I'm going to come over here, and I'm going to use the same trace I've already done and start from there, come over to here to the resistor, come up above it, come across to here, and do this in yips, back up a space, and come down and cut through my LED and come back over and end it up so I don't have to cut as much trace. Cut as much traces and cut as much traces and end that cut, and now I can come off from here. I have a lot of problems with this, but it's easy to fix.
It's not the most ergonomic laptop position either.
Oh, that's true too. I've got a problem with this, and so what I'm going to do, thank you for pointing this out. I've got 3 basic functions I do. I cut, but I'll show you those, but I got a lot of helper functions. And one is I can change the scaling in here, and I'll say I'd like to make this thing right here. I said change the scaling in here and make this thing right here a little bit bigger so I can see it easier. My laptop's kind of small. And what I'm doing is I have different keys that allow you to do a lot of different functions with it, and the keys will explain what they are. There's a list in here that tells you what all these different keys and functions do.
Very shortcut-driven first show.
Can I hear you?
You're very shortcut driven on the keyboard.
Okay. I'm gonna come over here. I still can't hit the right keys when it's a lot bigger. Come over here to that spot, come down here to this spot, come down here to this spot, and end up my cut over here. So I don't have very thin traces anymore, but I'm going to end it up there, and I have now cut out a circuit board. Does everybody see that will hook up the resistor to the LEDs?
We have to follow that here. Resistor across those two.
Power goes into the resistor.
LED across there.
I mean, that's very simple to do, I believe. Any questions about what that's done so far? Now the problem is, if I'm cutting out the circuit board, that's going to waste some circuit board. And so what I want to do here is I like to do a function which I call function M, which is a move. And I'm going to move this whole circuit cut down here to the corner of my board. So when I cut it, I'll only be a 2-inch board, 2-inch by 2-inch board. And so I can move it around. I don't particularly like this. I want the LED to be on the top. So I'm going to rotate it. Let's turn on the cap locks. I'm going to rotate it. Whoops. I'm going to rotate it so the LED is now on the top of the board. Now the problem is my power connector is on the right-hand side. I like to be on the side also, so I'm going to horizontally flip it, and now I flipped it. And so I have a lot of keys for manipulating the circuit board and changing stuff. It's too big for me to see exactly, so I'm going to come back down and move the board back down. So that is the proper size to show a circuit board. So the Easy Cut program is trivial. And but what it does, there's 3 functions I do. One function is I can drill holes. One function is I can cut traces. And the third function is to generate G-codes. And so when I hit that, I've generated G-codes. The problem is I don't like to sit down and hand generate G-codes. And so I like to build some circuit boards. I like to build lots of circuit boards. But I get tired of cutting them by hand, so I wrote a program to generate G-codes. I'm going to take a look at G-codes. I have a help file in here. Does everybody understand G-codes? I see a shaking head, yes, yes. And the
G-code would be the machine instructions for the individual movements to cut or print with a CNC machine or a 3D printer.
And if we make this a little bit bigger, it will look like a Welcome to Easy Cut program. I have a editor. I'm running Linux. If everybody doesn't know Linux, it has its own peculiarities with stuff. I have an editor, a text editor. All this is in text. First thing I'm going to do is take a look at the file that I just created. I'm going to tell this thing open up a new file. I'm going to go in. I have something called Frolics work. And I'm going to take a look at Frolics. And this is, I don't know if those numbers are big enough to see. The very first number, it's a bogus number. Programmed through it in there. Doesn't mean anything. The first column is numbers 1. It looks like I have 30 items. 30 items I put in there. The second number is a number 1. That's the first item I put. My code is extremely simple. It's a proprietary code, but anybody can do whatever with it. The first item, number 5, I started off not knowing what I was doing, and if I'm cutting traces, 0 and 1 did different things. A number 2 starts a cut. If you start a cut, you're supposed to keep going until you end a cut. And so as you continue on, you get a number 3, and when you end it, you have a 4. And so those are what the numbers mean. And then if you want to put a hole in, that's a number 5. And I started with holes, and so the very first number is a 5. And it says I put the first hole in at 1.15 over, that is the x axis over 1.15, and the y axis up a half. I'm going to go back and look at my board, if I can. Move this over and look at the board. And the first hole, it looks like, if I can see it, it doesn't look like the first, okay, where the first hole is, going to back out of my program right here. I can't because I'm an editor. But the first hole, the very first hole I put, I think was a resistor. And the resistor is in this area right here. And it's over at 1.15 and it's up at 0.55. So that should be the first hole, which is what I saved in my program. And the next hole on the resistor is the same distance over and a little bit higher. So the second hole is the same distance over and it's up 1 inch. You can go back and look at the program, and it looks like it's right above 1 inch. A couple of rules on my program. I don't like cutting lines through the middle of a through hole. You know, I don't want to cut out the copper through a particular hole. So if you're putting holes in the board, you always put them in the middle of a grid. So it's always, the grids are 1/10 of an inch, the holes are going to be 1/10 of an inch plus 1/20. And so if you notice, the cuts don't ever hit the holes. You can change all that if you want to. It's just all flexible and changeable. But that's just makes it very simple, straightforward rules. Yes?
It's a little bit difficult to hear, but you said that the lines were 1/10 of an inch?
Yes.
What if I have a smaller board? Would that not change the size?
Like on surface mount components, something with smaller traces and smaller through holes.
I have, yes, you can scale this. I'm playing with a lot of different scales. I have a function in here, the letter F will change you, if we do this correctly, which it should. I can't show anything on the easy cut board while I'm in the middle of an editor. But you understand, this is the edit file. And what I want to show you is I want to open up a brand new file, which is called, you can find it in here, easy cut, and we go into where the G-code files are kept. And we have a G-code file called Frolic Work G-code. I'm very ingenious with my names and everything. And so if we take a look at the G-code file, this is a G-code that was generated. And if you notice, we start off and it identifies what it is, comes down, and the first thing it moves to is X is 1.15. Well, first thing it moves to is X 0, Y 0. But we start off from the beginning and we move over to X 1.15 over to Y.055. And then the next thing we do is drop a drill bit into it, bring the drill bit back up, then we move to the next point and drill it again. And so the G codes that got generated are from the, I guess my proprietary matrix code that I'm saving. And so it should be a one-to-one relationship between the code that I generated from EasyCut and the G code. This happens to be, if I can find how to move this down slightly, I had generated basically, it looks like 57 G codes, which I don't like to do by hand. So I can instantaneously have my program generate a G code. Any questions about G codes and what I'm doing with it? Any questions about how to do this? Okay. I'm going to get out of the help menu and come back to where I am, and it looks like I have hit a few backup spaces. I did, and I'm going to back out of this. And if I back out of the program, I can find the very first button I put, which was at the X is 1 point. Well, I think I moved it a little bit since then. But X is over 1 and something, 1 point. Well, I definitely moved it because X, the dot is on the line. I can move this thing back to where it's supposed to be. I'm in a different scale. That's what's going on. I hit a scale factor. They asked about a scale factor. We started off 1 to 1, and I think that's where we're supposed to be to start with, something like that. And we'll put the rest of the program back together. And obviously, I put my first dot back in the wrong place. We'll move it back up a little bit, and we'll go back and cut it out. You shouldn't move things around until you know where you are and what you're doing. But that looks like the original program, I think. The program does 3 things. It drills holes, it cuts out pads, and it generates G-code. And then this is not saved and all. My program doesn't automatically save it. The G code is saved, but I'm gonna come and open up some other files I've been playing with. These are a lot of files I've been playing with for different people. This is a circuit board that I'm making, and it has, I think, 99 drill holes in it, and it gets a little complicated, but it takes a little bit of time. But I've knocked out several of these. Do you have a sample board there? This is not that board. This is nothing. Well,
You've got quite a few sample boards.
I make lots and lots and lots of boards. They're super easy to make. Actually,
You got a pocket full of boards.
pocket full of boards. This is a board that I made yesterday. Like, handed out to people. There, it hasn't been polished up. It hasn't been cleaned up or anything. I had a friend come to me. I'm going to a conference. I'm going to a meeting, and but can I please help him? He's got a anniversary coming up this weekend. He's trying to build 12 display units. He's got these acrylic panels, and he wants to put LED lights on them. And I said, well, you got to shoot them from the bottom so they come up to the middle of it. Well, how do we do that? Well, I built that is 9. I built several of those. That is 9 circuit boards there that I cut out, because it's a lot easier to wire up a huge amount. 72 LEDs it's got to hook up if you have circuit boards to put on, and it was trivial to do that. But if you hold that up to the light, you can look through it and you can see. You got a flashlight. That's even better.
Yeah, that board is somewhat unfinished. It's been cut, but it's still got rough edges on it.
Yeah, I need to. I've got a wire brush. There's a lot of different things.
There's a little bit of post processing needed to finish it before populating.
This one's been polished a little bit better. It's a lot smoother. That one's been polished. It's a lot smoother on boards.
So I think this is that layout.
You flip the board over, you're showing it through the front. You cut the board. You cut the board from the back. You don't cut the board from. You can look at the board. Don't tell me how I know that you can cut boards upside down and backwards, and all. But typically, you have the copper side up facing your bit, and you cut through the boards from the copper side, and which is the bottom. But then you flip it over and put components through on the top. And he's showing the top of the board, and all. This is the board these boards are a lot of fun to play with, but you have to have boards. You have to have a way to make boards. The actual raw boards materials, you can buy a blank board for under $1, and then you can have all the fun in the world with it. If you notice, these boards are square. I take a file and round off the sides of the boards.
Question for
I'm
you,
going to
sir.
need this one back in a minute. I don't particularly need it back.
Why would you want to use a circuit board like this instead of something a little bit more convenient like a breadboard?
I hate breadboards. I work on something with a breadboard. The wires fall out of it and move around. When I can solder something down, it stays there. I get called away constantly to do different things. I drop these things constantly, and when I come back, they still kind of work, kind of. If I don't tear them up too terribly much. I had a project. It had 9 buttons on it that I needed to play with, and so I built me a 9-button circuit board.
Excuse me.
Yes.
I see that you cut it in here on this size, but what if I wanted to scale it up in the program? How do I do that? Do I have to like redo the program to this size, or how do you scale it?
I'm not sure I exactly understand your question,
After you finish the design, if it turns out your board wasn't coming out the right size, if you had it scaled wrong, and if after you finish the file, then you come back to it and adjust it, scale up and down. I believe so.
you can Well, adjusting the scale does not change where the G-code gets the pins wherever you put them. You can always go back in and fix something. There's 100 times I've gone back in and fixed a little board or something. I'm going to do a scaling on my boards here. I'm going to bring this thing down a little bit, and I'm going to tell it now what I want to do is make the board 24 inches by 24 inches. Whoops, a little bit too high, so let's tell it to, well, we'll turn off the scaling and move the board down, and that limits it to 24 by 24.
So does that mean a bigger board?
A much bigger board. I limit it to 24 inches because most people in here, anybody build boards bigger than 24 by 24? No, and no. Not that you can't. And I have a CNC machine here to talk about. I'm not talking about CNC machines. I'm talking about EasyCut and how EasyCut works. But EasyCut, the third thing it does is generates G-code for a CNC machine. If you want to build a board, you have to have a CNC machine. This is not a cheap way to do things, but it is very fast. I had a John Deere tractor, excavator, that the controller board burned out in it. And it's the second time the controller board burned out, and everybody was upset. $450 to replace the controller board. Can I take a look at it? I said, sure. They gave it to me. Really nice board, glass cover, no way in hell to get inside of it until you cut the tar out of underneath the glass. Thing came up, and lo and behold, the board comes out, except it has two switches built onto the frame that have to be connected to the board, and you have about a 1-inch cable. Okay, if I want to test this board, I've got to buy me a special cable to go on my workbench, and scratch my head and say, what I'm going to do is build me a circuit board that has two switches in it. It took me 20 minutes to design it, less than 20 minutes to cut it out, and about an hour to put all the parts on it to get the board to work. But then I mounted it on the back of the controller board, and I had buttons on it so I could find out what was going on wrong with the controller board. But that's because I can build circuit boards and I do things. How many boards do people want to see? How many boards did I bring on?
Would anybody like to see some more example boards? Maybe with more components on them?
One of the things I enjoy doing is I came up with an idea that I'm an electronic hobbyist. I love to build prototype boards for everything. And
That's got a voltage regulator.
And so one of the things I'm doing, does anybody play with the Raspberry Pi Pico? Any electronic hobbyist in here? I built me a little board, circuit board, and put 3 Picos on it because I like to play with different Picos. And it's just a nice generic test board, but I have it for a particular reason with it. I have a particular little project. Apartments are small today. You don't have enough room to work on things, and so I came up with a concept and an idea. Since I can build circuit boards, I can build any size things I want. I have a little circuit board here that has a display on it, but it's tricky to play with, and it works. But I came up with a concept, a 3D printer, rubber bands. They're cheap, and I can come along here and build me a little work desk.
You hold down, or you hold this one, and I'll put that one together.
Okay. Probably a lot easier than me.
You hold down there.
I was building a little LCD display, and the problem with LCD display is it needs a bias voltage. The bias voltage is a negative voltage, and I don't have a negative voltage, but I can use a voltage doubler, but instead of doubling, I can do a minus. And so instead of taking 3 volts in and doubling it to 6, I can take 3 volts in and double it to -6 to give me a -3 volts, and that makes the circuit work. But how exactly do you build a voltage doubler to get them? I kind of know how to do that, so I sat down and just built me a little prototype, tested, because I can cut patterns out of boards and stick parts on them and move things around. But this is I call it a workbench on a desktop, and what I can do is sit up on my desk and work on things and do things. And when I finish, I can take it apart and put it back in a box and put it in a drawer, and my whole electronic workbench goes away, and I have a desk for doing other things, or our kitchen table to cook food on and other stuff. But when I want to work on it, I can go into my box and pick it up off the out of the drawer. And everybody has access to 3D printers, but you don't have access to circuit boards. But you do now. You can make your own circuit boards for doing stuff. This right here was my favorite. You put the wrong board in there. What I want to do is put this board in there because this is what I'm working on.
All right, thanks.
So that's fine. So what I'm going to do is take off. This is a nice board to work on. I haven't worked on it yet. This right here is my little workboard spot, and this can sit on my desk, and I can work on this sitting on the desk. And I have a little screen back here if I program it correctly, which I haven't done, but if I did program it slightly, and so it comes on. If I can get power plugged into it, the screen comes on, says hello world. Can everybody see this? If I change this pot, I'm changing the voltage on it, and the screen will, this is changing the bias voltage, and I've figured out how to do in software, change the pulse width to my voltage doubler and adjust the voltage in software. So I can adjust the bias in software with it. But I wouldn't have been able to do that if I didn't have a board to hook it together and put that on with. There we go. It gets bias is way too high there, etc. I see somebody back there that says, "Yep, that's how you do it," and everything. And so,
and that would be something that you would need to have adjustable because the LCD will perform at different temperatures. So you may design your board and get the bias voltage set correctly, and then take it out on a hot day and not be able to see it.
And so this has a Pico board up under here talking to this thing, and it's just part of my generic work table. The other side of this table is my current thing that I really enjoy playing with. Hard to play with this stuff correctly. I passed out a board a few minutes ago that was
it's got orange relays on it.
It's got four orange relays on it. And what I want to do, if I can, we'll plug that back in, and you can hook it up next to your microphone. I don't write good software. That's not what I do. I make circuit boards. I make good circuit boards, I think. These are not. This is another one, which I'm going to unplug from here because I have a very short cable. Same circuit board, 4 relays. This doesn't have the LEDs on it or push button switches. I don't always need push button switches and LEDs, but I put them on the board and use these until I get the project I want. Then I clean it up. But I have a lot of extra little. I dabble and play with circuit boards and hobbyist. Does anybody have a cell phone? Does anybody know how to connect to a website? Has anybody looked at websites around here? Addresses. See if you can find a website called Test4, capital T, capital E, capital S, capital T 4. Because I have an access point here. Access point is top one. Access point is my top board, and when it comes on, it generates a signal for test 4. Anybody find test 4 out there on their phones? See, one person said yes, they did. And I don't trust these things when it comes on and says, "Hey, I'm an access point, I'm test 4." I say, "Yes, prove it." I have a second Pico here that is looking, is scanning, and I'm finding hundreds, and well, maybe not hundreds. I found 70 some odd Wi-Fi signals in my hotel room here while I'm here. But this guy is scanning for Wi-Fi signals, and when he finds a Wi-Fi signal called test 4, he will turn on the red light. The red light is on. If I disconnect the power from this guy, he'll lose test 4, and that red light will go off. Which I'm not sure I can do that correctly, but trust me, I'll show y'all later if you want to see it actually activate and come on and go off. But I can just look at a glance and say, my test 4 board is up and running. Now test 4 is a like a Wi-Fi, it's an access point, a Wi-Fi router, and his address if you're on the network of test 4, you can log into it. The password for test 4 is password, all lowercase, PASSWORD. And so now everybody can get into my test 4 board. But what they don't know is this bottom board is looking for test 4. This bottom board is similar to this guy. You need to put that next to your microphone if you want to. Go ahead and touch a, that's not, I don't hear this relay click. Pardon? Hang on a second. Is that,
I wonder if it's talking to the other one.
it could be this guy. No, this guy didn't, it's not finished this. It's got to be that guy. But basically, as a test thing to play with, anybody with a cell phone can access my, this guy is also looking for test 4. This guy is looking for test, you're probably on the wrong, there are 3 test 4s, there are 3 PhreakNIC controller boards running here. This be one of them, that be one of them, and this down right here be one of them. One of them should be at point 192.168.4.16. One of them should be at .17. For some reason, I think my computer is on 18 or something. And then there's one of them that's actually, we can probably do this a little bit better if I actually take a look at it. I'm on test 4. If I can find me a terminal, I can do a ARP scan and be better if I type it correctly.
I got a relays.
Pardon? Okay. He has found this PhreakNIC demo, and he's actually turning these relays on remotely from his phone. Yes?
Maybe a new, what's the IP address?
What address?
192.168.4.19 for this board right
4.19. If you look at his phone there on the blue buttons, there you'll see that they turn blue and purple as he's turning this thing on and off. I don't see too many people playing with phones. Probably don't want to get in my network because it's actually all Chinese, and no, it's actually English. I think the decals is English. They're probably capturing everybody's phone numbers and everything. But if somebody else gets in and changes it, it'll turn on one of these relays. I thought about putting a 110 volt lamp in here and let people turn the lamp on and off, but then I just ran out of time on doing stuff. Somebody is changing that.
That's me. I have no idea what I'm doing.
It works, and the LEDs work as well.
Yeah, I'm clicking everything.
The LEDs are working.
Maybe a little dim.
I can bring that up on my computer, which everybody can see on the overall screen, I guess, here. If I,
You got to connect to the network first.
I'm connected to the network, I think. And let's see if you say that is 19. I think I'm connected to the network. Tell it to connect again. And it doesn't like me. And I am on test 4. No, I'm there. So I can turn it on here. Maybe I can turn it on here. It doesn't, oh, there we go. It likes that.
For a microcontroller, it's being a pretty good access point.
But this is why I build a lot of circuit boards, because I love playing with all types of different stuff. And I can build, a friend of mine wanted some remote control stuff, and I don't know much about the software and all, but I can hack it together. But I can build the boards to make the stuff work. And that's what I'm talking about is easy. I want to show you a few other things about EasyCut. If there's any questions about it, please let me know. I don't need a 24-inch by 24-inch board, so I'm going to see if I can turn this function back on and bring the board back down to a size. Oops, let's turn this function back off and bring the board back up into, no, didn't turn the function off yet. That turns the function off and bring the board back up. And boy, I've got a big board sitting down there. Let's turn my function back on. And I now have a 2-inch by 2-inch board, but if we scale this thing back up, figure out how to do all these things. We can scale it back up, and then we can try to move it around. And obviously my screen is not big enough to hold my board, and so I'm gonna make the board, we'll scale the boards back up. That's 4 inches by 4 inches by 3 inches, and that's the size boards I'm trying to play with. Now, going along with EasyCut, 1/3 of what it does is generates G-codes. G-codes go out to a CNC machine. I need to talk to a CNC machine. I've written my own communications for that, but I don't recommend my communications program. It's for me, it works, it does the stuff. But there are a lot of good communications programs. I'm not trying to tell everybody, hey, I got a great communications program. It's just, you have to, that's part of having this. And so I'm going to end EasyCut for a moment, or at least put it aside, and see if I can find, well, this is my communications program that's up and running. Can you see that one? It is small. That's because I don't know how to write great software yet, but and this is not an important part of my program, so it's small. I deal with it. But I basically have 5 functions that I do on my communications program, and the first one is select a port that you want to talk with. Well, I don't have a CNC machine I can connect to. I don't know if anybody uses CNC machines, if anybody knows anything about it, but they make this great software program called GRBL. I've been using it for 20 years or something. They've changed it recently to GRBL HAL, which is a hardware abstraction layer, and they make it run on a Pico. And I like Picos now, so I said, okay, let's do that. I have sitting around here someplace, I don't see it right here, that's not it. It doesn't matter. I have designed a board to take a Pico and break it out to the GRBL pinouts. And they make many different flavors of GRBL. They have a deluxe edition, they have different things. And I can't read all the software stuff very well. This fellow right here, Mr. Frolic, wanted a controller board, and so I designed him one. And
Controller board.
that is the controller board that comes with the machine, but he wanted his own controller board, and so I built one. But he said, which pins do what? And I said, I can figure them out. But I decided, let's just build him another board, which I don't have. He's got it somewhere.
We did spend a long time reading the source, attempting to figure out which pins were mapped where in the GRBL HAL firmware that you can build online. And despite many hours of reading through the source, we could not figure out where they had some of these pins mapped.
I couldn't find the right one for whatever. So I built me a generic Pico board and put LEDs on every pin. And I ran the GRBL HAL software on it, and when I said move the x-axis, one pin was toggling, and I said move it backwards, another pin came on, and the first pin toggled again. That's the X step pin, and that's the X direction pin. And I did it for Y, I did it for Z, and a couple other things. And it took me 10 minutes after I built the test board to figure out what pins run the GRBL HAL. If anybody has an interest in having their own controller board for one of these machines, I'll be glad to build them one. It's trivial. And he took my board and all the LEDs on it because he wants to use it for other things. I have a GRBL HAL board which I've used not on this machine, but I have a couple of them that I've used, and he has one. I think that I don't know if he's using it or not.
It works. It drives.
And so I can build stuff. And the main thing is I want other people to be able to build stuff. And I didn't say this was cheap. You have to buy a CNC machine. But they're coming out with, I think it's called MP CNC. And I don't know what it stands for. Somebody told me about it here last night. But the people are taking their 3D printers and changing them into CNC machines. But if you have a CNC machine, you need to generate G-codes for it. And I have a program that'll do that. And I'd like, if people like it, it's not finished yet. And every time I finish something, somebody says, can't you add this? Yes. Can't you add this? Can't you keep making this thing grow forever? Yes.
Can you cut a two-sided board or do something cool like an inductive coil?
Well, you can do double-sided boards. here.
I was gonna say, shine some light through that one. Yeah, hold that one up to the light.
Yeah, I like it. Well, that's the light. This being a double-sided board. You can do double-sided boards, and as a lark, as a test, I said, can I make me a energy coil? Can I make me a RFID reader coil? Can I do something? And I said, probably. And I said, I can make a double coil. I can make one on both sides. And I tried to lay it out. I'm not the best on laying out stuff, but supposedly you have a pin on one side that goes to the center, and then you have a pin on the other side that goes to the center. The whole thing is absolutely symmetrical. And if you wire them up correctly, you get a double coil, or you can wire them up to have a transformer between. It's just, it was a test. I've never tested it. He took it away from me.
They can be used for stuff.
Did I touch a HDMI cable? No, my computer went to sleep. It does that. What I wanted to show you, first thing I need to do is connect to a CNC machine. And so I have 5 commands on this program. The first one is Control B, and it gives you a list of possible ports. And I pick a port, and it says that port's not connected, which I know it's not. But that's beside the point. The next thing I can do is select a file. That's Control F for file. Control B is for baud rate. Control F is to select a file. You have a lot of files that generate G-codes on. If we take a look at, should be your name.
Frolics.
Frolics. F. I can't see it on here. Frolics. It's where's Frolics?
Very tiny text.
Pardon?
Very tiny text. Oh, I see it. 14.
Number 14. Okay, 1,
Actually,
4,
13.
13, 1, 3. I have selected Frolics, and that is my selection. I can actually kind of tell that board down there kind of looks like the Frolics board I had. If I chose a different board, it'd do something different. If I told it to Control R to run, my program comes up. I draw 2 copper type of backgrounds, because mostly I play with 3 by 4 inch boards, but sometimes I play with 4 by 6 inch boards. And so I just pop them back there, and I show if this thing runs, which is supposed to run, and it doesn't run very well when you don't have a CNC hook to it. And this probably, no, it's not running, but it runs, and it changes the white dots into dark dots as you as a CNC machine finds them and drills them, and it changes the green lines into white lines as it cuts them. And so it gives me a picture of what's going on the CNC machine. It's not absolutely accurate because this doesn't know how to, it knows how to talk to the CNC machine, but the CNC machine doesn't know how to actually tell if it's doing things or not. Are there any questions about this type of stuff? Any questions?
You have an electrical engineering degree?
Yes. Went to a little trade school down in Atlanta, Georgia, off North Avenue Trade School, across from the varsity. Some people call it Georgia Tech. And so, but I've never worked as a professional draftsman. I took drafting courses at Tech, loved them, and I've just always loved the hardware. I have, most of my friends all became software engineers. I'm a hardware engineer, and there's just a different philosophy and idea on stuff. I had a friend of mine had a design problem. He sent me the design one Saturday morning, and I sat there and built the board and put it together, had all the parts, and sure enough, it didn't work. And I was able to troubleshoot it and said, oh, these are the problems, the biasing, offsets. So I rebuilt the board and tested it, and it worked, but not well. So I sat there and tweaked everything, and it worked very well. And that night I sent him that board. It's the very same day that he sent the picture to me. I was able to send the board back to him. I had a friend that worked for a little company called Hewlett-Packard. They had a manufacturing plant in Colorado, old Colorado, I think. The engineers were on the second floor, the manufacturing plant and the cafeteria was on the ground floor. And when the engineers wanted to get a soft drink or something, they had to leave their office, go downstairs, go to the vending machines, come back up the stairs, and come back into their office. And after a while, they got tired of that, so they decided to buy a Coke machine for their office. And after a few months with everybody running around saying, got change for $1? I need 50 cents, I need this. They said they can do something better. They put a controller inside the Coke machine so they can just wave their badge in front of it and have somebody keep tabs on how many times they got drinks out of it. And they talked to the engineering department and said, can we have one of our badge readers? And the engineering department at Hewlett-Packard thought about, I guess, 10 seconds and said, if we don't give them one, they will take one apart and figure out how they work, and we'd rather just give them one. So they gave them a badge reader. And then a buddy of mine I went to school with said, we got to build a board. And they called me, and he called me, and I said, I'll be glad to build you one. I built him a microprocessor board. I don't write microprocessor code. It runs YGAN, which is some type of protocol or something. But I sent him 2 boards, and he programmed them, and said, they work perfectly. They put one in the Coke machine. I said, put the other one inside the change box in the Coke machine, because you're not using it anymore. And so they did that. And for the next 5 years, every few weeks, I was on a mailing list and got a note, the Coke machine jammed something or another, or somebody's out of something, and all these messages came back and forth. My friend left Hewlett-Packard, and about 5 years after that, I kept getting messages from Hewlett-Packard all the time. And one day somebody said, we had a lightning hit or something, a power glitch, and the Coke machine circuit board's not working anymore. Does anybody know how to fix it? And dumb me, whatever, I wrote them back. Yeah, there should be a spare board in the change box. And they said, who the hell are you? You're not on, you never worked for Hewlett-Packard. How are you in our internal mail stuff? And click, I never got another message from HP. I want to say, at least I have built circuit boards for a nice American company before. They're not great boards or anything. I used to build boards, I have some examples here, I think, of boards I used to build. I used to build great looking circuit boards. And these boards, you cannot get very close. What happened to the CNC machine?
We're 5 over on the.
I am sorry.
Yeah, we're in the
We're in somebody else's
question period.
Oh, okay. Thank you. That's why I have somebody else here. I'm blind. I don't see things.
I was supposed to tell you 5 minutes ago.
Okay, you're supposed to tell me that. Thank you. Does anybody have any questions about how this works? There's a lot of things I haven't gotten into on this.
We have much more material.
But does anybody, if you want to buy a CNC machine, I got suggestions and ideas on how to do it. I bought him one and gave it to him one Friday afternoon. Saturday morning, he got it at 2 o'clock in the morning and spent 5 hours putting it together. And then he couldn't make it work. And frustrated him for a couple of days. He came back to me and said, well, there's a lot of things on GRBL you have to know. And I showed him how to do it, and he got it up and running. I've even made boards in his machine. I know a lot about circuit boards and a lot about CNC machines. Any questions from anybody?
Yeah, come track us down if you have any questions, and we will show you literally anything you have questions about. We'll show you how it works.
I'll give you the code for all of this stuff if you want it, but this is not. This is just why I make circuit boards, so I can play with all this stuff. I don't understand what I'm doing with this stuff, but I know how to make circuit boards to play with. If you notice, none of these switches are connected, but they're on here in case I want to play with something different than these switches. And so, but that's. I think I pretty much covered everything I think that y'all want to hear. Hopefully.
Is this the part where we clap?
Pardon?
Is this the part where we clap?
I guess, unless anybody wants to know anything else. And thank you.